Welcome to my presentation for MDA512 Assignment 2. My project is about used car price prediction. The goal of the first part I did is data cleaning. I get the source of data from Cargo, which is web scraped from Craigslist. I handle the NAN value. I drop columns with too many empty values in rows and also rows with too many empty values. I define too many to be 50%. If it is more than 50%, they will be dropped. I handled outliers, which means they have zero car price or the car price is too extreme. Here I define extreme to be less than $3,000 and more than $100,000 for a used car. I also drop data which are not relevant to business analysis. Say if the car is having a car year before 1995, they will be dropped. And if it is new car, the car price will be zero because the car dealer wants to get zero down payment only. That is not the actual car price. This data would be dropped. Also columns which is about the URLs like the image URL, geographical location, and the dates the advertisement is posted will be dropped. After cleaning, you can see the distribution of car price is about having a mean of $20,000, minimum $3,000 as outliners were removed, maximum $100,000 as outliners were removed. Then I did data analysis by plotting charts between car price and car year, manufacturer, car model, car condition, odometer, paint color, fuel type, and car type. As you can see, there is a sign not on the car model because there are more than 500 car models. I just group them into 30, get the top 30 car models and group all the others to be the group in other. On the right hand side is the car price by year. As you can see, the newer the car, the more expensive the car. The bottom one is the car price by the fuel type. As you can imagine, there will be different car price for different fuel type. But it is not usually hybrid or electric. The new technology will be more expensive. Some case for pickup on truck, for example, hybrid and electric would be cheaper than the gas and the diesel. Then it's come to the chart for the top 5 manufacturers' average car price by condition. As we know that new car will be more expensive than fair car, but you can see from this chart that for different manufacturers, the gap would not be the same. For Ford, for example, it contributes to about $30,000 between new and a fair car. But for Honda and Nissan, it's just about $15,000 between new and fair car. And then it comes to the charts for price relationship with transmission type. Here I plot the top 10 popular models and see that we know that automatic and manual car have a gap. But again, the gap is not the same on different models. Some models would have shown about 20,000 gap between automatic and manual. Some models would just show about 2,000 in gap. On the right hand side, it is about the car paint color, and you can see that people have different preference on the paint color with regarding to different model. Some models they would show higher preference for some color which may not be that favorite in other model. And here it is the pair plot for the numeric values in my data set. As you can see, the price is actually right skewed, and an odometer is also right skewed, while the year is left skewed. I did a decision tree to get a car price prediction. I did investigation about classification and regression tree, and I found that regression tree is more appropriate for this project as for getting car price prediction. I need to define tree depth though. If I don't define tree depth, the tree would grow too large, but it would have more accuracy. If I have a small depth, the price prediction deviates too much from actual values. After some trials, I define my max depth to be 10. The result of my decision model, after fitting the dataset into the regression tree by scikit-learn, is plotted on this right-hand side. As you can see, the actual price and the predicted price, they show more or less linear relationship. That means they are quite close. And with the matrix, you can see that I have the mean root mean square value to be about 6,000. Remember that the mean car price is about 20,000, so it is a fair prediction. Not excellent, but it's okay. The bottom right-hand corner is the decision tree. As I mentioned, because the car depth, the maximum depth is about 10, so the tree is actually quite large. Theoretically, we can see the decision made in each node, but this is not able to show in this presentation. About future work and conclusion. So there is a high potential of this project. A service can be created to allow people to estimate used car price by providing a predicted value by asking the user to enter the attributes. Or a combination of data can let us do a trend analysis and to see people preference change over time. If we have data for worldwide car sale, we can also do analysis for worldwide car sale. My conclusion is these tools are very useful: scikit-learn, Matplotlib, Seaborn for plotting, NumPy and Pandas for manipulating dataset, scikit-learn for decision tree and regression tree. They are all very powerful tools in doing data analysis. That's it for my presentation. Thank you.